So yeah, like a 20. Oh, so 20 on the quiz means that you got half of the problems wrong, right? And that's most people at the moment, right? So you want to figure out, what went wrong and how can we fix it? And so let's try to work on that. I'll begin with a word of prayer. So, Heavenly Father, we thank you for this morning. Thank you for this class. Just pray you be with us. Help us to understand the mathematics together. We thank you for your love for us each and every day. And just please guide our steps today, Lord. In your name I pray, Lord Jesus. Amen. Okay, so yeah, there were 40 points. Other questions? Usually people ask me, do we also get the sheet of notes front and back for the test? Yep. You can bring the same sheet if you want. You can make a new sheet up. It's up to you, right? I don't collect them. You should save those so you can bring the sheet to the final exam, right? Here's something people got wrong almost universally. And so in all the review sessions I've done so far, I have spent at least a little bit of time talking about, and so I will project the solution for the later part of this review session, but at the start, let me just talk about completing the square again. So let me do one of the examples on the quiz just to illustrate completing the square. So let's talk about factor completely over R via completing the square. And I think technically that wasn't even, well, I guess that was the instructions. I mean, problem 3, I just say factor by completing the square. I didn't say over R, So I guess technically that could have involved the complex numbers, but I don't expect you to factor over the complex numbers on this test, right? We'll save that for later. Anyway, let me get to it here. So this one, 5x squared plus 14x plus 8. This factoring problem, this factoring problem right here, some of you got stuck on this one, right? I don't know if you remember or not, but some of you did. So let's talk about how we could factor this by completing the square. All right? So let me show you. So the step number 1 is if you have a leading coefficient which is not 1, you need to factor it out. So how do you factor 5 out? Well, that's easy enough for the first term, right? But you got to use your imagination. That's plus what? 14 over 5 x plus 8 over 5. All right, so there we go. Step number 1, rewrite it so that the leading coefficient's 1, all right? Now I'm going to complete the square on the thing in the parentheses, all right? So what's the first step? We want to do what? Take the coefficient of x and divide by 2. What's half of 14/5? 7/5. Very good. So we take 7/5, x plus 7/5, so we square it. Now completing the square, we have to subtract the square of the number we added here, right? So I subtract 7/5 squared, right? And I still have to add the 8/5 over here, close parentheses, right? Now let me just do a little bit of arithmetic here off to the side. What's 7/5 squared? Is what? That's 49 over 25, right? What is 8/5 in terms of 25ths? 8/5 is what? It's equal to 40 over 25, right? If you multiply by 5 over 5. So in view of that arithmetic, this is actually minus 49 25ths plus 40 25ths. So the net result there is what? So you got minus, how much? Minus 9 over 25. Right? Do you guys see that? Now, you can rewrite 9 over 25 as the square root of 9 over 25 squared, right? Now, what is the square root of 9 over 25? So what is that? That's what? So that's the square root of 9 divided by the square root of 25, which is 3/5, right? So I really have x plus 7/5 minus quantity 3/5 squared, right? So what is this? This is the difference of squares, right? Remember what we said day one? Remember? One of the first things I told you guys, a squared minus b squared is a plus b times a minus b, right? So this is the difference of squares. So look at this here. Think of this as what? A quantity squared, and this is my b squared, right? So this is the pattern, a squared minus b squared, so I can factor using this template, right? And so here it is. 5 times x plus 7/5 plus 3/5 times x plus 7/5 minus 3/5. Now we've factored. This is factoring by completing the square. This one's uglier than the one I gave you on the quiz because the leading coefficient here was 5, right? But this is problem 1b on version B of the quiz. So this is number 1b. Now, I didn't ask you to complete the square necessarily in problem 1b, right? So let's finish this though. We can clean this up, right? What's 7/3? 7/5 plus 3/5 is what? 7 plus 3 is 10, right? 10 over 5, 2, right? So we've got x plus 2. And what's 7 minus 3? 7 minus 3 is 4. So that's times x plus 4/5. So that's a perfectly fine answer, like there, right? But we could multiply the 5 through the second factor. What would that give us? If we multiply the 5 through, we're going to have x plus 2 times what? Times 5x plus 4, right? Now, some of you got that for your answer for part 1b, right? How did you get that as your answer for part 1b? You just looked at this, right? You looked at this, and what did you do? You made the template, right? 5x, x, and then you thought about, well, how can I get 8, right? I can get 8 from what? 1 times 8, or 2 times 4, basically, right? And then you thought about plugging in these numbers, seeing which worked, and after a bit of trial and error, maybe you found 4 and maybe you found 2. Now, some of you didn't find those because you got stumped on this problem, right? So, what I'm advocating here is you should have completing the square as a method of factoring as a fallback. If this, what I wrote in red, doesn't work for you, right? If you can't see your way through the numbers, you can fall back on completing this. There's no guessing in here. There's not a single guess in all of this. It is an algorithm. You factor out the x squared, you take half of this, you square it, you subtract that number squared, you do the arithmetic to clean it up, you do the difference of squares. There's no guess in here. It's just an algorithm. Once you understand it, you can factor literally everything like this. Is that how you should factor everything? Certainly not, right? This is way, way easier if you see it. But what if you don't? Right? Let's look at another one. Can I erase the arithmetic because it's kind of in the way for my next? Yeah. I mean, I'm not saying that this is for free. This does come at a cost, right? The cost is the arithmetic. Yeah? Here's another one if you had something like, 2x squared plus 8x plus 10, right? Again, we want to factor by completing the square. I haven't done many of these examples with a leading coefficient, which is not 1, so I'm doing a couple for you today. So first order of business here, factor out the 2, right? Right? So then you guys help me out. What comes next? If I want to complete the square on that, what should I do? I divide this by 2, right? So I do x plus quantity 2, I square it, right? And then I have to subtract the square of whatever I added. So I have to subtract 2 squared, which is 4. Right, so those two terms I just wrote are exactly equal to what I've underlined above. And of course the 5 is still there, so plus 5. Now I clean up, right? So now I do the arithmetic. The arithmetic here is way easier, right? No fractions. The arithmetic here is just 5 minus 4, which is 1. Okay. Well, this is really different, isn't it? So this one here, compared to the previous example, what's the difference? Do you see the difference? After we do the arithmetic and simplify, we have, so with this one, we had the square minus the number, right? But here we have the square plus a number. So what this means, if we complete the square and you get the square plus a number, that means it's a prime. This is a prime polynomial. What's that mean? That means that you can't factor it with the real numbers, right? So, you know, I should really modify the instructions if I'm going to have this as a possibility. I should say something like factor if possible, if not, you know, say that the polynomial is prime. You had lots of homework like this, right? But my quiz didn't really quite test that nuance of things. I'm not saying that that's not on the test. Certainly you should know what a prime polynomial is for the test. So I try to stick somewhat close to the format of the quiz for the test, but this is like one thing I do need to change a little bit. I think I haven't properly assessed whether or not you guys know what a prime polynomial is on my quiz as I think about it. So there are 3 things that can happen completing the square. You can get a negative number, right? You can get a positive number. So that means it's prime, right? You need complex numbers to factor it. What's the other thing that could happen? What if you had like x squared, you know, plus 26x plus, I don't know, 169. What happens if you complete the square on this one? So we take what, half of 26, let me make it minus 26 to make it more interesting. Okay? So what happens if you take half of 26? Well, minus 26. So we always add half of the coefficient of the linear, of the coefficient of x. If it's positive, you add the positive number. If it's negative, you add the negative number. So in this one, we do x minus 13 quantity squared, right? Now to be fair, I've just added 169 by doing that. I've added 13 squared. So I have to subtract minus 13 squared. Of course, I mean, I wrote the minus here just to emphasize the interplay between these two terms, but you need to put a minus there. Not really, you're squaring it, right? You know the minus is going to kill the square anyway. I'm just saying, you know, it's the square of whatever goes here, I subtract there. Anyway, what is minus 13 squared? It's 169, exactly. So in fact, this term is this term. They cancel, and you're just left with x minus 13 quantity squared. So in this case, what did completing the square do? Completing the square actually just straight factored it for you. So when your polynomial, when your quadratic is actually just a square, completing the square will just straight factor it, right? And of course you could have seen this by doing the template thing, right? If you did that, Well, you'd have to understand what 169 is, right? You'd have to understand that 169 is what? 13 squared. If you didn't see that, then it's really hard to progress on this. But I don't know. So that's in. Well, I guess that's the difference between factoring here, right? If you're factoring here, what makes that slightly harder is you'd have to understand that 169 is 13 squared, right? With completing the square on this problem, you don't have to understand that because it's an algorithm. You subtract the square of this. See, I didn't need to know that 13 squared was 169 to make this step, but I do need to know that 169 is 13 squared to factor, because the first step of factoring is understanding how the constant term breaks up into pieces, right? So I am trying to urge you, make completing the square part of your mathematical tool set, because it can get you out of a lot of corners, all right? Any questions? There was also in the test, let me just reference this before I forget. At the end of the test, right, one of the problems is find the domain. So if you had this version, some of you had the version of the test. I asked you to find the domain of the function, and the function was, what was it? It was f of x equal, I think it was x minus 2 over x squared plus 4x plus 5, right? So some of you like incorrectly factored this to x plus 1 times x plus 5 or something like that, right? That's not true because the middle coefficient is not 6. Actually, this you can understand by completing the square. See, because we just did it, the denominator here is x plus 2 squared plus 1, right? By what I just did, I mean, essentially what's in parentheses over here. See it? So we complete the square on x squared plus 4x plus 5. It is x plus 2 squared plus 1. What can I see from this formula? What I can see from this formula, what is manifest from it, is that this is never 0. Right? It's never 0. Because you're taking something squared plus 1, right? Something squared can't be negative. In fact, if you think about this for a second, you'll see that the denominator, the smallest it could possibly be is 1. That happens when x equals to minus 2. Anyway, my point is, no division by 0. So does this formula ever break? It does not, right? This formula is defined for all real x. So this tells me that the domain of f of x, in fact, was minus infinity to infinity. So like completing the square is important, not just to factoring, but also to understanding the structure of formulas, because completing the square will reveal when you have a prime polynomial, among other things. All right. Let me get the projector out and we'll go through the other problems one at a time. I just wanted to spend some more time with you guys on that because, uh-oh, sorry. Everybody got the notes? I can hold the thing up if it's a problem. So I already talked, well, did I already? Oh, I haven't already talked to you guys yet. I keep forgetting. You guys are not like the others. So in the other sections, we had a Friday meeting after, after the quiz. But of course you guys did not, right? So the thing I talked about first, and I should talk about to you guys as well, and I will once I get the quiz out here in front of us. So I hope everybody top hatted. I want to put this away. Gabrielle, did you? Okay. 20, let me just do a quick count here. 6, 7, 8. Yeah, we're good. So do you guys know where the solution to the quiz is? Everybody found it already? So I'm asking because every so often I have somebody who didn't realize it's posted there, right? But I'll try to make a habit of that, guys, like as we go on. Once we have a quiz or a test, I'll try to post the solution in the section in Canvas under the what's it called? The Learn section, right? Okay. Anyway, in the module where the assignment appeared, I'll try to put the solution right there, okay? So All right, so these problems, so there's like a fundamental, I told the other sections this, I'll tell you guys too. I think the fundamental confusion of college algebra is confusing the problem of factoring with the problem of solving. Do you understand the difference between factoring and solving? Let me just, So if we had x squared plus 3x plus 2, right? And I say factor that. Factoring is just this, right? Factoring. If I say to solve x squared plus 3x plus 2 equals to 0, that is a different problem, right? Factoring, you begin with an expression, you end with an expression, right? So the factoring problem, oops. Sorry, I'm adjusting my, well, I'll have to remember to come back here once I'm done with this. So this right here, factoring, right? The answer is an expression, right? There's no equals to 0 in the factoring problem, right? There's just no equal to 0 there. Here, this is an equation. We factor the polynomial, right? We set it equal to 0, and then we use the 0 property to say what? So either x equals to -1 or x equals to -2, right? So this is solving. Solving x squared plus 3x plus 2 equals to 0. These are separate problems. Are they related? Absolutely, right? If you can factor the quadratic, then you can solve it, right? But many of you, I've asked you to factor here, and what you're doing is you're solving it, right? A lot of you. Because, like, you get stuck on this one, for example, you're solving it. You're just going to the quadratic equation. I mean, that's nice, but that's not factoring it, right? Factoring is this. Solving it is something else, right? You need to pull those two things apart in your mind, because if I ask you to factor it and then you solve it, it shows me that you don't really understand algebra. You want to convince me you understand algebra. That's like your goal, right? If there's something you don't understand, you want to somehow hide it from me. Like, don't make it obvious, like, I have enough points. I don't want any of yours. Okay, so, all right, let me put this. Let me zoom back out here. Any questions? So, listen, with complex numbers, the complex numbers will only appear for you guys in, like, solving. Let me show you what I mean. So if we go ahead here, problem 4, for example, see, here I have 3x plus 7 squared equals to -17. So I take the square root of both sides, I use the square root property, right? Square root property puts a plus or minus over there, and then that minus becomes, the square root of -1 becomes I, so I get I root 17, okay? So that is the sole context where like complex numbers are likely to appear on your test or quiz, all right? So I'm not going to ask you to factor over the complexes, okay? So another example, x squared plus 1 equal to is what? How would you factor that? So the way you'd factor this would be x minus I, x plus I. Okay? How would you solve this? You have x squared equals to -1, so that gives you x is equal to plus or minus the square root of -1 plus or minus I. So will we factor polynomials over the complex numbers? Sure, eventually. But this is for later, okay? That's not on your test. But in contrast, down here, solving the quadratic equation when the solution's complex, that could happen. It did happen right here, right? So that's there. I wanted to make sure I clarified that because I have done an example or two where I factored with complex numbers. I'm just telling you I'm not going to test you on that just yet. Let's go back to the page 1 here. So, all right. So this guy here, a lot of you said, some of you said it couldn't be factored, right? But the thing about this is we can think of 7 as the square root of 7 squared, right? And so we can factor that. Because we're factoring over the real numbers, right? So the square root of 7 minus the square root of 7, these are real numbers. We're allowed to use them in the factoring. This one we've already talked about. I showed you how to solve it with completing the square, right? This one here, so like, here's an example where if you tried to use the completing the square algorithm, it would be a real drag, right? Like if you tried to use the algorithm I did at the start of class to do this one, it would be a pain. This one really is much, much better with the template approach. Don't forget about your sum of cubes formula, right? If you've got x cubed plus 8, that sort of yells at me, I'm a sum or a difference of cubes. So we have the formula for a cubed plus b cubed is this. I just put, a equals to x and b equals to 2 in there. And this is how it factors. Fun fact, whenever you do this, the quadratic that appears here will be prime. If you completed the square on this, you'd have x minus 1 quantity squared plus 3. So we complete the square, you get a plus. This is a prime polynomial. Anyway, that always happens when you do this formula. The polynomial which appears here ends up being prime. But this one, if you've got 4 terms added, it pretty much is going to be factoring by grouping. I don't think I really have other problems with 4 terms. So just as a rule of thumb, if you got 4 terms, it's probably factoring by grouping. So factoring by grouping is what it kind of sounds like. So I pull an x squared out of these 2 terms, and then I just use my imagination to see a 1 over here. I've got a common x plus 3, so I can factor it out, and this is x squared plus 1 times x squared plus 3. We're done because, again, x squared plus 1 is prime. So don't feel bad if you got this one wrong. Totally understandable. I did not spend a lot of time on factoring by grouping in here, did I? But it was in your homework, and it is something you should have seen before. But I figured you probably needed another refresher on this, so that's why I put it on the quiz. It does come up sometimes. Let me switch my view here. You guys just jump in if you got a question or something, all right? Otherwise, I'll just keep talking. Go for it.
Can you go over how to do problem C and English test? Verb 9.
Yeah, here it is. So let me make it bigger. Do, 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 do. All right, so C, yes. So this is a very good first step, right? X squared plus 9, x squared minus 9. I bet you did that, right? You did that. But the thing is we're not done, right? Because this still factors to x plus 3 times x minus 3. So I'm trying to factor completely, right? So we have to keep breaking things down until we're left with prime polynomials. And so, yeah, the thing is the x squared minus 9 splits into 2 pieces. So I did give, partial credit for the halfway there, but there's a little bit more. And now this one here, whenever you see something squared minus something, you should be thinking difference of squares formula, right? The a squared minus b squared is a plus b times a minus b. So identify a as 2w and b as 3 here. That's what I did. I'm not factoring in the sense of I'm not putting the template down and guessing numbers to put in for this kind of problem, right? I'm just using the a squared minus b squared equals to a plus b times a minus b formula. There's no guessing involved here. Okay, anyway. Any other questions about problem 1? Yeah, go for it.
Can you go to problem 7?
Yeah, sure. You guys don't have to remind me what I missed if we do this though. Let's see here, 7a. Let's see if I've got the right version. Did you got that one, or the other one? The other one. All right. I'll get to it eventually. There it is. Yes, I would say there are two things that stand out in my mind that the class needs to work on as a whole. The one is completing the square. The other is the nonlinear inequality method, right? So a lot of you on problem 7a, either this version or the other, what I was faced with is like just like a wall of text, like a paragraph of stuff, but no number line. And if you're doing that, I don't know what you're doing, but it's wrong. Unfortunately, I mean, it's wrong. Because, well, you don't find the answer among other things, but so it's very, the method is that 4-step process I was talking about, right? Step number 1, identify the critical numbers. So here, you've got -7, 6, 3, and -1. Those are my critical numbers. I must put them in order on the number line, all right? And then I have to test points, right? So there's various approaches, but I think 0 is a nice thing to look at here. 0, I get 7. And then, careful here, if I put in 0, I get -6 squared, right? Which is a plus. I saw that get one person. Everything else they did was right. But they plugged 0 in here, got -6. It made everything else they did wrong. So it's a good habit to double check the point. But anyway, so that's +7 times 36 times -27 times 1. So you've got basically plus, plus, minus, plus if we plug in 0. So that's a net minus. So that's why I got minuses here between -1 and 3, because that's where 0 is, right? Another way you could think about it, if you put in a super big number, right? Like put in 1,000. What do you got here? 1,000 times 1,000 squared divided by 1,000 cubed times 1,000 squared, right? They're all positive. So if you think about it, it's fairly clear that this expression will be positive if you go far enough to the right. So that's another thing you can do. Think about putting in a really big number. It's easy to think about that. A really big number doesn't care about the 7, the 6, the 3, or the 1, right? If x is 1,000, what does it matter what 7 minus 6 or 3 or 1 are? Anyway, once you do that, then we can use the sign flip idea to propagate the minuses. So like here, I'll start with this one. If I start with the plus, I get the 6. Why don't so I get past the 6, I stay plus because it's x minus 6 squared, right? So the sign does not flip because it's a square. X minus 6 squared, sign maintains. I get to 3, that's from this x minus 3 cubed. That's an odd power, that means the sign flips, right? I get to -1. -1 is from this x plus 1 squared, that's an even power. The sign does not flip, it just stays minus to minus. I get to -7, again it's an odd power, the power is 1 here, so we flip the sign. So if you check 2 points and then you also use the sign flip idea I'm talking about, then you have like a double check on your number line. If you want to be really, really redundant, you can test a point from every single different case and check on your signs, right? But that takes a lot of time, doesn't it? Right? Does this make sense so far? Or? Okay. Oh, yeah. So good question. Good question. So the bulk of the answer here, less than or equal to 0. So we're looking for minuses, right? And so -7. Now -1 I have to exclude because -1 gives you division by 0. So I have to exclude the -1. See that? So I go up to -1, don't include it. Start at -1, but don't include it on the other side. Go to 3. 3 is also excluded because it's denominator, right? But then we have to stop back and ask the question, what's the problem? The problem is less than or equal to 0, right? I've definitely got all the less than in here. But do I have all the equal? Equal to 0. See, equals to 0 happens at -7 and 6. So I don't have 6. So I have to union with 6 because that's another place where it's 0. If you had everything here but you missed the 6, I'm very sympathetic. I gave a lot of partial credit, right? But and I would give proportionately more partial credit on the test because the test has like more points, so I can give more nuanced partial credit. So like on the test, I would give like 90% credit for this and like dock like 10% probably. On the quiz, I took off more like 30% probably for that. But that's just because I'm lazy with my grading. But yeah.
So if it's equal to 0, it's included, and if it's not equal to 0, it's excluded.
Right, if it's equals to 0, we have to think about what numbers will make the numerator 0, but at the same time not make the denominator 0. If the denominator is 0, we have to exclude it. Like there's, those numbers are excluded. Let's talk about the other one of these problems while we're on it. Yeah? So if you didn't get that problem, I would urge you to go back to the lectures that we did on these. Like go to the start of my example, write the problem down, work it for yourself, and then watch what I did. See if you can reproduce what we did in class. I think we have at least like 4 or 5, if not more, examples of these kind of problems. Not exactly this, but things like it, right? I'm pretty sure I spent about an hour of class on these because they're difficult, you know? This one, the critical numbers are -7, -1, and 5/4. That's what makes this 0, that 0, that 0. So those are my critical numbers. I test points. I get the minuses and plus like this, right? And then I'm looking for where it's less than or equal to 0, so I go the minuses, right? And this time, look at this. Something different happens in this problem. See this one, it just so happens that so first of all the critical numbers are zeros in this problem, right? So you have to include all of the critical numbers because we're looking at less than or equal to 0. But the interesting thing with this one is all of the critical numbers end up being on the edge of the regions that we already have. So we don't end up having to do that union of 6 thing like we did in the other problem. So, you know. So, I mean, each quiz has its difficulties, right? Like quiz A and quiz B, they have separate difficulties. There's quirks and features. Like in this one, see problem 6, part C here, this one? A lot of you put, what did you put for your solution here? You put -1/2 and -5/2, right? Some of you, and you got it wrong. The reason you got it wrong is because of that -2, right? If we cannot have absolute value equal to negative number, if you had taken your solutions and plugged them back into the problem, you would have found out that they didn't work. -1/2 and -5/2 gives us absolute value of that quantity is equal to 2. Both of your solutions are extraneous if you got the minus problem. In contrast, the other version of the quiz, right? The other version of the quiz had 2x plus 3 equal to 2. In that case, both -1/2 and -5/2 are solutions. You can plug them back in, you'll get 2 each time. Right? So just be on the watch out for this. If some evil math professor gives you absolute value equal to negative number, don't make work for yourself. Just be like, hey, stop that. There's no solution to that. You jerk, right? I mean, you don't have to write jerk on your test, but if you want, I mean, I'd allow it. But I used to study with a guy who, if he got annoyed with one of the graders, so he used to like code messages into his homework using like randomly placed capital letters. So he'd be like spelling out "you are a moron." Like if you just kind of like take a step back and look at the whole page, it would say that. It was stuff like we'd be up till 2 in the morning finding a solution, and then like we'd do an algebraic simplification, then the grader would count it wrong because they didn't know like the stuff we're going to teach you at the end of the semester. You know, if you wrote an answer which was different from what they had in the answer key, they would count it wrong sometimes. It was like, come on, you're supposed to be, they're physics graduate students. They're supposed to know these things, you know? All right, another related comment. If you have absolute value less than a negative number, game over, end of story, not possible. Absolute value has to be greater than or equal to 0. So if you run up against a problem like this, you don't have to work. You just have to say, no, that's not possible. Done. Solution set, empty. So, I mean, there's no algorithm here. It's just basically common sense. And that sense may not be common to you yet, and that's okay. That's what we're trying to learn together, right? In contrast, this one here, instead of having a -2, I had a 2. That makes the story totally different. is right, because 6 minus x less than absolute value is the absolute value of 6 minus x less than 2. What is it? What is it?
Oh, what did you say? It was less than 0?
Oh, if you have, so if we have like absolute value problem,
Yeah.
one of the, like the fundamental property of absolute value is it's either greater than or equal to 0. So if you have a problem where you're asked to solve absolute value of stuff, I don't care what stuff is, but if that stuff is less than 0, you can't do it. So the other problem was this, but less than minus 2. That problem has no solution. Like the solution set is the empty set. In contrast, this one, you just use one of our boxed, remember the two results we had for the absolute value less than, we do minus 2 less than the thing inside the absolute value less than 2. Then you isolate x. That's the solution, right? It is important to me that you write the solution in interval notation. Some of you have written your solution like this or like that. Like that, you're going to lose significant points if you just do that. I do want the solution in interval. If I ask for interval notation, I do want the solution in interval notation. Interval notation is like this, or with the unions, when you need a union of things. All right, so please do pay attention to that. It does matter. Let's see here. Let me go back to problem 3. I think we already talked about completing the square enough today. Anybody want me to talk more about it? No? All right. So that one, you can complete the square to solve that. The problem 4, we use the square root properties. This is like already made to order. This is in these problems. Well, this problem is pretty easy because you've already got a square, right? If you've already got a square, you can just take the square root of both sides, use plus or minus square root property, right? And solve for x. So I get 0 or minus 6 there. In contrast, b here was a little bit more of a pain because in b, I did not have a square given to me, right? So I had to create it. So I did that by completing the square. And that put a minus 2 over here. Took the square root of both sides. And I got plus or minus 2i. And I got that. Now, some of you are using the quadratic formula for this problem. Right? Was that acceptable? The answer is yes, it was totally acceptable. However, if you're going to use the quadratic formula, you must finish the job. All right? So like don't leave the formula half evaluated and like not, you have to work it out. For this one, a lot of you got it wrong because when you did the quadratic formula, your division only applied to one of these numbers but not both. So some of you had like minus 4 plus I square root of 8, or you had a minus 4 plus the square root of minus 8. Let it be understood that if we have a problem like this, I'm going to add some language at the start that says if the answer is complex, please simplify your answer and leave it in Cartesian form. What is Cartesian form of a complex number? It's the a plus ib form. Like this is Cartesian form. A plus I times b. So I do, if you're going to use the quadratic formula, I do want you to simplify the numbers in the formula, all right? So you can use it, but be aware that I do expect you to like do the math, do the arithmetic there. So no, I don't think it was wrong to use the quadratic formula, but quadratic formula comes paired with the responsibility of simplifying the formula. Look, see, I've used the quadratic formula here for problem 5. Because, I don't know, completing the square on this problem, it's just kind of ugly. Because you get fractions, you get like a quarter plus 24, and that's not fun. So it's about the same difficulty, I'll use the quadratic formula. So I did, and I got minus 1 plus or minus square root 97 over 2, at which point I'm like, okay, well, those are not integers. Now some of you have asked me what are successive integers. Successive integers are numbers that come one after the other, right? Like 4 and 5, 23 and 24. One of the students in one of the other sections was like, 24 is the product of successive integers. Do you guys know? So here's what he said. 2 times 3 times 4. So my wording was ambiguous, wasn't it? Because I should have said the product of 2 Or if I had said the product of a pair of successive integers, then the answer is definitely no, right? But if you allow for 3, or even 4, because you could add 1 to this, 1, 2, 3, 4 is successive. The product of 1, 2, 3, and 4 is 24. Yeah, this is my misfortune. So, but here's my larger misfortune here is many of you got complete credit for this. But what did you write? Did you write this quadratic equation? You did not. You wrote a couple of sentences, right? And you told me about factors of 24. You're like, well, 24 has factors like 1 and 24, or 2 and 12, or 3 and 8, or 4 and 6, right? And none of those numbers are successive, right? Integers. And those are all the possible ways of factoring 24. Therefore, no, 24 is not the product of successive integers. Right? Now, you didn't say it quite that logically complete, but that was your idea, reading between the lines. And so I gave you credit. But that's not the solution that I wanted. This is how we did it in class, you know. This is using algebra. You used what's called number theory, right? Or number sense, let's say. And for that reason, this problem is dead to us. Because it does not test what I need to test on the test. So like, this is not on the test. I don't say that too much, but this problem, not on the test. So I much more, I think the other applied problem, this one here, this one is better for the test, or something like it. Or, you know, the other problems we had in the homework also with the pictures and such, those are kind of more suited. Because I don't think you can do those with just guessing in numbers. Unfortunately, the successive integer problem, it was fun. But this one here, this problem is very interesting in that, so some of you set up the problem right, give or take. I didn't have many people actually solve this problem with the algebra altogether. Some people did, a few. But it was somewhat rare for someone to actually solve this problem correctly. And I think this one's interesting in that, look at this quadratic equation that you end up with, 2x squared plus 5x minus 250. It's kind of a mess, isn't it? I mean, that's kind of a nasty looking equation. And I solved this by what? What is this method I used here? Basically, I was using completing the square to solve it, right? And I think this is a good example of one where maybe I made the wrong choice, right? Maybe I would think it's arguable that like my choice of completing the square here was not the best choice. I think quadratic formula here is just as easy, maybe even easier than what I did, right? So ironically, this particular problem, which has actually kind of nice answers, right? 10 and minus 12.5, the quadratic formula would have been a better choice here. I'm answering a question that none of you have asked, which is, should we use the quadratic formula or not? And the answer is sometimes, right? I try to factor, right? Factoring is always better if you can do it because it's easier. If factoring fails, I use completing the square. If that looks like a pain, then I'll fall back on the quadratic formula. Other questions? Yep. Yeah, similar but shorter, because the first section said it was too long, and I said, okay, fine, I'll make it shorter. I don't think it's too long, though, honestly. Like, this is pretty typical length for test in here. But I have pity upon you guys, and also I'm lazy, so I'm going to cut the length of the test down, so, I mean, less grading for me. But that does mean each problem has more points, so you have to be careful, right? But I mean, I don't see that. I don't think making a shorter test in that sense, like if I go from 4 pages to 3 pages, I don't think it really changes much, honestly. If you're going to make a certain number of mistakes on 4 pages, you're going to make a certain number of mistakes on 3 pages. I think it all averages out, honestly. There comes a point where this is no longer true, right? Like if I just test 1 problem, then it probably doesn't give me an accurate representation of your skill set in here, does it? But I probably can gauge what you can do with 3 pages just the same. Let's talk about the last page on the test. Other questions, though? I mean, jump in. So the last page
Part C of the previous problem, it was the greater than problem, right? Remember absolute value greater than? We have to do less than -2 or greater than 2 for this problem. I get two separate inequalities, I solve them. This is the solution set for the one, that's the solution set for the other. I have to take their union to get the solution set for the whole thing. So as something to look out for, if we have absolute value greater than, expect the solution to be a union of two different sets, right? If we have absolute value less than, you can expect the solution to either be nothing, because the number's negative and the professor's messing with you, or it's a interval like 4 to 8 in the other problem. Problem 8, f of 2. So literally all you have to do here is take this x and replace it with a 2. That's it. Now if you got this problem wrong, that's good news, because this is very easy for you to fix, right? If you got the number line inequality problem wrong, you might have a bunch of things you got to work on, right? If you got the completing the square problem wrong, you might have some things to work out, right? But this is easy to fix, right? So function evaluation, we just plug the number in and do the math. And there are people who were looking at like f of x equal to 0 or something weird here. I mean, I don't know. Let's look at the other one before I... So the other version, I had f of x is equal to x squared plus 7. Again, literally all you do is take the x, replace it with 2, and do the math. 2 squared is 4, 4 plus 7 is 11, all there is to it. Problem 9, we talked about earlier. So the domain of this is all real numbers, because if I complete the square in the denominator, I see it's never 0. The other version of this problem was more exciting, right? And so here I could have the denominator 0, right? The numerator has nothing to do with anything. What happens if if x is equal to -3? If x is equal to -3, that makes f of -3 0. That's fine. It could be 0. That doesn't rule it out, right? But denominator 0, that's a problem. So when x equals to 4, we must avoid that. So x is not equal to 4. So my solution is the union from -infinity to 4 and 4 to infinity. That's that one. So if you got the function graph problem wrong, do not give up on this problem. You can get this. You need to get it. It's not hard, but you have to set some things right in your mind. So first of all, I asked for the answer in interval notation. Some of you have just given me like a list of numbers here. Like some people have got like 5 or 6 numbers just written out here. Like, I don't know what to do with that. It's not an interval. I don't know what to do with it. I really can't. I don't know what to do with it. I need intervals. Now f of -2, so we look at -2, right? What is f of -2? The reason it's -6, see right here? The dot's filled in. That means f of -2 is -6. That's our convention for the graph. Filled in dot tells you what the value is. Open circle means the value is not there. If it's an open circle and there's no dot, like for example here, f of 2, what would we say? F of 2 would be DNE, does not exist, because the circle dot here. F of 4 does not exist, right? All right. The domain, these are the allowed x values. So look at it. We start at -8, go all the way over here to -2. It's here, right? And then it keeps going all the way to 2. So we've got -8 all the way over to 2 to start with. We jump here from 2 to 4. And we start again here at 4 and go all the way over to 8. So 4 to 8. So that's the domain. The range, if you look at it, we start at -6. That's the low point, right? And you go up and you look for y values. Anything missing? Nothing missing, right? I get up here to 8. That's the high point. So the range is -6 to 8. Both of them included because a solid dot here and a solid dot there. Everyone can do this problem. You need to understand domain and range from a graph, right? Everyone should be able to do this problem. Problem 11 is not hard. It's basically, there's two versions of it. One's parallel, one's perpendicular. For perpendicular, you need negative reciprocal of the slope that's given. This has slope 3, so the perpendicular line must have slope -1/3. And then I just used point slope. I know my point is -1/4, so point slope tells me I put the y value here, and I subtract the x value there. I put the slope of minus 1/3, formula. There you go. This is the formula of the perpendicular line through 4 comma minus 1. If you simplify it, it gives you slope-intercept form of minus 1/3 x plus 11/3. Either of these totally legit answers. It come out a little bit prettier in the other version. So the other version, problem 11, so this time I had point minus 210, so I do 10, the slope is the same if it's parallel, right? So 3 leads to 3, and then x minus a minus 2, and then you simplify it, it ends up with 3x plus 16. Again, this right here also would have been a legit answer. Let's look at this one. It's a little bit different, right? So here, what's the domain? It goes from minus 8 over to 4, right? 4 is not included, but 8 is. Then you jump over here, start again at 6, go over to 8, so 6 to 8, like that. The range, on the other hand, is a little bit more annoying for this one. See, because you have y, your lowest value for y is minus 4, and you've got a continuous output of y values all the way up to 4. That one's missing, so we go minus 4 to 4 from this part. And then we jump up here to 6, go from 6 to 8. So that gives me 6 to 8 for the range. But again, you can do this, right? Everybody can do this. There's no reason to lose points on this problem if I put it on the test, right? So, I mean, something's got to give, because I told you I was going to reduce the length of the test a little bit, right? So something's going to be missing, but I'm not telling you what just yet, because I want you to try to understand the whole quiz, right? Except for the successive integer problem, which is dead to us. Yeah. Ah, so f of negative 8. Good question. So we look at minus 8, right? Look at the graph. Right there.
Oh my god.
It's okay. So, right, like I said, you can do this, you know? I know you can do this. Right. It's I don't know. I had a graduate course once where I got my test back, and it was like I lost, I think, I don't know, 5 or 10% of the grade, and I'm like, what did I do? What did I do? And it boiled down to, like, I subtracted 5 instead of 10 from something, or something like that, or I subtracted 5x from both sides, but I subtracted 10 instead of 5 or something. I'm in graduate school. Do I know, like, the right step? I absolutely do. So why did I make the mistake? This is the thing. It's like you learn what you can, right? But you have to accept we live in a fallen world. You will make mistakes. It doesn't matter how much you study. We all have our own, talents and gifts, and it's just the human condition. Like, we make mistakes. So do the best you can, but that's all you can do. So anyway. So I think that's it. I'll stop here.